Hi there. We're going to start to deploy ASA in a high availability fashion. We're going to start by ensuring high availability at the interface level by using redundant interface feature. And this feature allows us to have a pair of interfaces, one in active state and another in standby state, so that if the active state fails, traffic should be forwarded over the standby interface. So let's just see how to do that. So my ASA right now is blank. So I'll be using E1 and E2 interface as my inside, as for E0 and E3 as my outside interfaces. So first thing, let me enable the other interfaces as well. E3. So we'll start by configuring inside interface. So I have to say what are the members, and it's going to be E1 and E2. Make sure there are other options that we can add at the interface, because it just looks like a normal interface inside. And I'll set the IP, and I believe that for this one I should be using 10.1.1.12.1.255.5.5.0. Okay, let me confirm. And I have both interfaces. Now it might be useful to use the MAC address, like a virtual MAC address, so that it doesn't affect the traffic for routers, because ASA won't send gratuitous ARPs. So if the MAC address is the same, well, the change will be seamless for the other routers. So let me just MAC address, and I'll say AAA BBBB 111, and I should be able to reach 10.1.1.12.1 and 11. So probably reach missing something. Let me see. Just show you on the brief. Heavy lantern and interface 10 and 11. It's here, VLAN 10, and this switch should be, I'm using 1 and 2, so it should be 01, 03. And it's not. Okay, so interface right. 1 and 03. Switch ports. Host, switch port, access, VLAN. And 10. Just make sure that. Oh, okay. Okay, that should be okay. Just show spanning tree 4 1. Okay, so that should work now. And 12. Okay, so let me just enable OSPF here. 10.1, 12 and 1 mask, and area 0. Okay, so now let's look at the outside interface. And it's called redundant 2, and the members will be E0 and E3, and MAC going to be AA BBBBB 2222. Name is going to be outside, and IP should be 10.1.4.5.1.255.4.5.5.5. No shot. Okay, let me confirm. Name if outside, so I should be able to reach 10.1.4.5.5. So probably something with my layer 2. The show VLAN brief, VLAN 145. So it should be on 0 and 0 1 and 1 1 and 0 2. Oh, that one missing. Oh. 1 1 and 0 2. Switch port host, switch port access VLAN 145. Let me confirm. And 0 2. Okay. Shows spike and just confirm. Okay, so should work now. 10 1. Why not? What might be missing? 0. Oh, using a different address. Let me just change ASA because R4 is using probably the same one. Just show. Yeah, let me change here. IP 192.120.1 255.255.255 192.124.5 and enable SPF as well. 1 255.255.255 area 0. And I should okay, yeah, you can see adjacency is up, show SPF neighbor. And just to test my policy ICMP, I have to change something here to global policy. Otherwise ping won't be accepted. Correct. I see. So let me test from R11. Whoa. Four. Okay, and I should be able to get to 5. Yeah, it's working. Now, if we test, so right now we have 2 interfaces, and you can see that from switch, where is switch 112? We can see that the MAC address on E1, so it means that E1 interface on ASA is being used and the other one is not in use, which means that if we shut down this interface while sending traffic, that shouldn't be affected. Yes, and shut E1, and we see there's one packet there that missed. Okay, was very quick, and we should see now its traffic is using E2 on ASA. So we can have redundancy at the interface level, and the same should be true for int show run redundant show run int redundant 2. Yes, same should be true for E2. If we shut this interface, so probably is using E3 instead of E0. Where is it? Page 31, yeah, that's the one. And if we look the show mark alias VLAN 10 145. and that should say 1111. So this is the interface currently being used, so that you can see the MAC address that was defined. So that's it, guys. We're going to proceed with the next feature.